Algebra 1, Unit 4, Lesson 1, which is covering exponential functions. So we are going to hop right on in and start with the warm-up and just review some line stuff. So if you notice, this is in slope-intercept form, y equals 2x minus 4. So that negative 4 tells me that my y-intercept is negative 4. And then 2 for your slope tells me to go up 2 and over 1. And then you connect the dots. So then for number 2, my y-intercept would be negative 1, or sorry, not negative 1, positive 1. And so we plot that at positive 1, and then our slope is negative 3 over 2, so we go down 3 from our y-intercept and right 2, and then we connect the dots. And keep in mind, you could have also gone up and left instead and still gotten the same result. So then for number 3, simplifying without a calculator, since this is 5 to the negative third, the negative exponent tells us that we need to move it down below, so it's going to be 1 over 5 cubed, and then that becomes 1 over 125, because 5 times 5 times 5 is 125. So then for number 4, we have 10 times 3 squared. Remember, order of operations, we do our exponents first, so this would be 10 times 9, which is just 90. So then for number 5, we have 7 times 2 to the negative 1. Since that's 2 to the negative 1, that's like 1/2 because you have to move it down to the bottom. And then you're just multiplying straight across, so it's just 7 over 2. And then last but not least, negative 3 times 2 to the 4th power. Remember, that's 2 times 2 times 2 times 2, which is 16. And then negative 3 times 16 would give us negative 48. So exponential functions, their standard form is y equals ab to the x power. And all of these letters kind of mean something in real world scenarios. So y is going to be your ending amount or ending value. So that would be after, like 5 years or something, how much money do I have in my savings account? Something like that. And so then for A is actually going to be the initial amount that was that you started with. So whether it is a bank account or a savings account, whatever it may be, doesn't matter. A is the initial amount. Or where you start. So then B is going to be your growth or decay rate. So if it's increasing by, let's say 50%, you'd have 150 or 1.5 there because you have that growth. And then X is your number of cycles or changes, whatever it is that you're plugging in, because this is the number that changes. So if you're talking about a bank account, it may be number of months. If you're talking about a retirement account, it may be in years. It just kind of depends on the situation. But X is going to be the number that is changing, that you're seeing what the result is. So in example 1, we want to evaluate using the domain -2, -1, 0, 1, and 2. And then we want to know, as domain increases, does our range increase or decrease? So starting with this, we want, and actually I'm not going to make a table. So with this, we're going to have to plug in all 5 of these numbers. So I would have f of -2 equals 2 to the -2 power. And so 2 to the -2 power would be 1 over 2 squared, or 1/4. Okay? And if you were making a table, it'd just be -2, 1/4. And so then we plug in -1, f of -1 equals 2 to the -1. Since that's a negative exponent, that tells me to put it in the denominator. And so that just means f to the -1 is 1/2. Okay? So then we plug in 0. F of 0 equals 2 to the 0 power. That would give us 1, because if you recall, anything to the 0 power is always 1. Then when we plug in 1, f of 1 equals 2 to the 1st power. And so that means that f of 1 is just 2. And then last but not least, f of 2 equals 2 to the second power, and 2 squared is just 4. And so as our domain is increasing, -2, -1, and up, notice our range values, or what it's equal to, is also increasing. So range increases as well. Okay? So then if we do the same thing, except with this function down here, and actually I'll do it with a table form this time so you can kind of see another way of looking at it. We always use -2, -1, 0, 1, and 2. And so then, if I want to evaluate this is going to be -4 times 3 to the -2. And 3 to the -2 would be 1 over 3 squared. And that is like -4 times 1/9. And when you multiply straight across, that's -4 over 9. So then when we do -1, that'd be 4 times 3 to the -1, which would be like -4 times 1/3, which would just be -4 over 3. Okay? So then with 0, we would have -4 times 3 to the 0 power, which is like -4 times 1. So that's going to just be -4. Then with 1, we'd have 4 times 3 to the first, so -4 times 3, which is going to be -12. And then I ran out of space just a little bit, but -4 times 3 squared is going to be -4 times 9, which gives us -36. Okay? And so with this, notice our range values are decreasing. Okay? So when we graph exponential functions, we are going to make a table of values using the domain -2, -1, 0, 1, and 2. And keep in mind, the little fancy brackets are just helping you know that that is domain. And so then we're going to plot the points and then connect the points to form a smooth curve. And it does need to be smooth. Don't be like a robot and just straight line it. That's not good. So our domain or our x values, we already know, -2, -1, 0, 1, and 2. So then we're going to plug that in. 5 to the -2, 5 to the -1, 5 to the 0, 5 to the first, 5 squared. Some of you may even start at the bottom and say, hey, that's 25. That one's 5. That one's 1. And if you do it that way, it actually makes your life a little bit simpler because then notice we divided by 5 to get from 25 to 5, divided by 5 to get from 5 to 1. 1 divided by 5 would just be 1/5, and 1/5 divided by 5 would be 1 over 25. And in case you didn't see that, this would be like 1 over 5 squared, and 5 to the -1 would be like 5 over 1. Okay? So then when you plot the points, you're just estimating. I do not expect you to be able to actually graph 1/25. I understand. But I do expect that you can graph 0, 1, and that you can graph 1, 5, and 2/25, which would be like way off the graph. So you just kind of put a point and you draw your smooth curve. And with exponential functions, they actually have something called an asymptote, which means they will never ever pass a certain point. In this case, it's basically whatever number is the next whole number below the numbers that you have fractions on. So since my fractions are 1/5 and 1/25, the next whole number below that would be 0, and so my asymptote's at 0. But that is about what your graph would look like. Okay? So as the x values increase, what happens to the y values? If you notice in the picture on the right, as those x values are increasing, my y values are also increasing. So then to state the domain and the range of the function, domain is x values. I can plug in any x value I want because it's anywhere that this graph is true and it goes on forever in both directions. So my domain is going to be Negative infinity is less than x, which is less than infinity. Okay? Or you can say all real numbers. That would also be fine. Or if you know the fancy symbol, it's an R with 2 lines. And so then for a range, we are looking for the lowest point. My lowest point is at 0 because that's the point that I can't cross, but I do go up forever. So because of that, I'm going to have x is greater than 0. I'm not going to have it be equal to 0, though, because I can't actually touch 0. Okay, so it's just x is greater than 0. So if we wanted to graph negative 2 times 6 to the x, we are still using the same domain, negative 2, negative 1, 0, 1, and 2. And we're still plugging it in. Negative 2 times 6 to the negative 2 power, negative 2 times 6 to the negative 1, negative 2 times 6 to the 0, negative 2 times 6 to the first, and negative 2 times 6 squared. So remember order of operations. When we have 6 to the negative 2, that would be like 1 over 6 squared, which is 36, which would give us negative 2 over 36, which simplifies to negative 1/18. Okay, and so then when we do the next one, that'd be negative 2 times 1 over 6, which would give us negative 2 over 6, which is negative 1/3. Then 6 to the 0 is 1, so it's just negative 2 times 1, which is negative 2. Negative 2 times 6 would give us negative 12. And negative 2 times 36 would give us negative 72. Okay? So then we plot these points. So we have negative 2, negative 1/18. So we know it's below that axis. Then we have negative 2, negative 1/3. Then we have 0, negative 2. 1, negative 12. 3, 6, 9, 12 is going to be like down here. It's already off of the graph. Boo. And then 2, negative 72 is going to be way down there. So we're just not going to graph that one. Actually, let me think. No, it's fine. So then we connect. We draw our smooth curve so we don't touch 0. And then it keeps going. There we go. Okay, so looking at this graph to state the domain, remember that's x values, this would be all real numbers, or negative infinity is less than x, which is less than infinity, because we can have any number plugged in. So then for the range, that is y values, and if you notice, it starts at 0 and then it goes down. And so since it goes down, I'm going to have x has to be less than 0 instead of greater than 0, because you notice greater than 0 is above the x-axis, less than 0 is below. And again, it's just going to be less than, not less than or equal to, because 0 is never actually touched. Okay. So for number 4, still using the same x values, negative 2, negative 1, 0, 1, and 2. So when we plug that in, we'd have 3 times 1/2 to the negative 2. So think about it. That 1/2 gets flipped, so now it's like 2 squared, which would then be 4, and 3 times 4 is 12. So then we do the same thing to change colors. 3 times 1/2. Oh, wait, what am I? Oh, no, never mind. So then, oops, to the first. So then when we flip it, we would just have 3 times 2, which would just be 6. Then we have 0, so 3 times 1/2 to the 0 is obviously just going to be 3 times 1, so that's just 3. Then when we plug in 1, we have 3 times 1/2, which would just be 3 over 2. And then with 2, when we plug that in, we have 3 times 1/2 squared, so that would be like 3 times 1/4, because we squared the top and we squared the bottom, and so then that would be 3/4. So then when we graph this, we'd have negative 212, 2, 4, 6, 8, 10, 12-ish. And then we have negative 1, 6. And then 0, 3. 1, 3/2. So that's 1.5. And then 2, 3/4. Okay. And again, we cannot touch 0, but we are going to come down. Oop. Smooth curve it. Perfect. So then looking at this graph, my domain is the same as it's been the entire time. It's still all real numbers. So whether you choose to write it as an inequality like I am, or you just write all real numbers, that's fine. And then your range, because you're going from your lowest point to your highest point on the y-axis, again, we can't touch 0, so x has to be greater than 0. Y has to be greater than 0. I just realized if y has to be greater than 0, that means these ranges should also be y. Oopsie. Sometimes I mess that up. So don't be like me. Make sure that when you're talking about range, your letter that you use is a y, because range is y values. My mistake. Bad teacher. All right. So last bit is the equation y equals x to the fourth, an exponential function, y or y not. Well, this is not an exponential function because the x needs to be the exponent, not the base. X needs to be the exponent. So if we had, let's say, y to the 4x, that would work. That would be exponential. All right. That is all I have for you. If you have any questions, please feel free to comment below or like the video if it was helpful. And let me know if you have any questions or need anything. We will see you later.